So, to quickly summarize, I discussed variety of issues of dynamic range, what it is, and related back to also things like how we can see some details of dynamic range and how we can capture that kind of information in real scene. We basically talked about how image acquisition pipeline is aimed at capturing the scene radiance, and we want to use that to convert to pixels. We basically talked about a variety of linear and nonlinear aspects of the image acquisition pipeline. Again, remembering that really what we want to do is capture the scene radiance of a real scene and convert it to the pixel values, and how the whole pipeline works and how we can represent and model this. Then we basically talked about the whole idea of camera calibration, which was aimed at basically using a lot of data, a data-driven method to be able to map the information about what scene radiance was and what pixel values were. This allowed us to create a profile that can be used to then, of course, do the opposite. Given a pixel value, what would be the best scene radiance for it? Then we basically talked about how to do this mapping. Basically, how do we go from pixel values to different exposure images and render a new radiance map that captures the scene. And then we talked about how tone mapping could be used to take the radiance map to then display an image in the displays that we have available. There is a lot of work out there in the HDR area. I'm just listing a few of the papers here. Other papers I will make available also on the website, so you should be able to look at them carefully. These are the ones I referred to in this slide deck. And of course, there are lots of softwares out there. I encourage you to look at things like Exposure Fusion. That's an additional method, builds on a whole lot of stuff that we talked about and builds on Xplan photography. And of course, these types of HDR images now available on your cell phones.